Hi friends, in this video we will see the concept of measures of dispersion. Let's take two samples. These are the data sets, sample 1 and sample 2. Let's calculate the mean and median for it. We have got the same mean and median. It means like both of the data sets are the same distributed, similarly distributed. Exactly, it's no. The answer is no. So we cannot, looking at the mean and median, we cannot say the data is distributed. Yes, looking at the mean and median, we cannot say the data are distributed same. So here the concept comes the measure of dispersion. What is measure of dispersion? Measure of dispersion tells us how the data are spread out, or how the data points are scattered within a data set. Mainly, it tells how much the data deviates from the central value, mean, median, or mode, which we discussed in the previous videos. So, under the measure of dispersion, we have this many topics. For today, we will see about range, IQR, and quartile deviation. These many topics we will see in the measure of dispersion. For these topics like range is also called as max minus mean, interquartile range in short we call it as IQR, quartile deviation it's a semi-interquartile range, the mean deviation, average absolute deviation from mean or median, variance, average square deviation from the mean, standard deviation, square root of variance. First three topics we will see in this video, and the next three topics will be covered in the next video. Let's say a range. What is range? It is the difference between the maximum and minimum values in a data set. For example, this is our data set. Max is 90 and minimum is 50. So 90 minus 50, it is 40. The range is 40. What is the large range means? Data is spread out widely. The range value is small means points are very closer. What is the disadvantage of using this range means it does not consider the intermediate values, since it focuses only on the extreme values, so intermediate values are ignored here. So what only the advantage is it gives a quick idea of how the data is spread. The disadvantages is do not consider the data distribution, how the values are spread within the extreme points. So when the range is used, the range is used in the initial data analysis, like extent of variations. Comparing two data sets quickly between to see which has a wider spread, then also we make use of range, and also the extreme values can be identified. If the range is too large, means we will come to know some outliers will be present. This is the usage of range. Let's see the percentage. We already know this since we have studied in our school days. The percentage is like part divided by whole banded. It's represent a proportion out of 100. Like if you scored 80% on a test, means out of 100 you have scored 80. Means like you are expressing the 80 in terms of 100. This is the way to express a number as a fraction of 100. For example, a student scores 45 out of 100, and how to calculate the percentage is in place of part you are fitting it 45, and then whole marks is 100, so 45 banded into 100, this is the 45%. Now let's see the percentile. Percentile is different from the percentage. Percentile, it tells a relative position in a data set. For example, if you have scored a 90 percentile, means among your total strength, the 90% of others, you are better than the 90% of others. It means like you score 90 percentile means, but in percentage, if you score 90 percentage means out of 100 you have scored the 90 marks. That's the meaning. So for percentile, it tells the relative position of value in a data set. It means what percentage of data falls below a given value. mainly it is like what percentage to focus is to what percentage of data falls below a given value. This gives the percentile. If you see the example, we will have a more idea on this. Percentiles divides the data into 100 equal parts. For example, 25th percentile means 25% of data is below Q1. This is 25th percentile means it is first quartile, 50th means it is a median, and 75th percentile means a third quartile. We will see the meaning of quartile in some time. So to calculate the percentile, to calculate the value at a given percentile, this is the formula. Like among a data set, you have a data set and you have to calculate what value lies on, for example, at 30th percentile. Take an example of 30th percentile. Firstly, you have to do is you have to arrange the data in the ascending order, then determine the percentile rank index. Then you have to determine the index. So to determine the index in the among the data set, when you arrange the index only at the, we can look at the what percentage the value is given. So we have to calculate this index. For to calculating this is a formula is P divided by 100 into N. P is what is the required percentile. For now in our case we are discussing on 30th percentile. So fill as a 30 and the total number of values in the data set. How many number of data will be there? Fill it and then you will get an I value. Based on this I value, we will locate the data value in the data set. Like if it is a whole number, then we will take the average values of I and I plus 1 and then we say this value will be located at the 30th percentile. If it is a decimal means, then we will be rounding up to the next integer and then we will locate at that position the value given will be at like example 30th percentile. If you see an example, we will get a more idea. Now for example, to find 30th percentile, the data given is 5, 10, 15 and so on till 50. This is already taken in a sorted order. So then now we are calculating the I. We want a 30th percentile, so we have written here 30 and then this is 100 in the formula it is same. So P by 100 into N. So N is the total number of values is 10. So on calculating we are getting a 3. If it is a whole number, then means we have to take the averages of values at position I and I plus 1. So if it is a third, the index is 3 means we have to take 15 and 20 average, then 17.5. This means that at 30th percentile the 17.5 will be a data, means somewhere around between 15 and 20th our 30th percentile would lie. This is the meaning. So now let's see the another example. The same. Now we are calculating the 75th percentile. To find the 75th percentile, apply the formula 75 by 100 into number of values 7.5 we got. If it is I value 7.5 means we have to round up to the next integer, as we have already seen the rules here written over. If it is a I decimal, then round up to the next integer and take the value at that position. So the at 8th value, since the decimal the I value is 7.5, so at 8th value we have calculated that the 75th percentile would be 40. So if you see the data, the 8th value 1, 2, 3, 4, 5, 6, 7, 8, 40th. This is the 75th percentile, 40th. 40, the value 40 will be the 75th percentile. Okay, now let's move on to another example. For example, you have already in the data set you have already given the data value. Now the question is like, what would be the percentile of the value 30th? We have already the value, then we have to calculate the percentile. Here in the previous examples percentiles were given, we are asked to locate the data value, but here directly the value is given. If we have to calculate the percentile, like this would be like whether it is 25th, 25th percentile or 30th percentile, 40th percentile, then we have a formula. If the value is already given, to calculate the percentile means B is the number of values below the given value. We have the data is already sorted out, so we can easily calculate how many number of values below. For example, in this case we are calculating for 30. So the below 30 we have 5 values. The same B value is 5. We have filled here, and the number of values below the given value. B is the number of values given the value. This is 5, and P is the percentile rank, which we are going to calculate, and then into 100. N is the number of values. Total number of values in the data set is 10. So we have got the 50th. This is the 50th percentile. Means the data, the 30 will be a 50th percentile in our data set. Now let's see the quartiles. What is the concept of quartiles? Quartiles divides a sorted data set into 4 equal parts, where each part contains 25% of the data. The 3 quartiles are Q1, Q2, Q3. The quartile plot would look like, one second, the diagram is below. This is the quartile plot. Q1, Q3, Q2. This is the meaning of quartile. It means like it will completely divide the whole data set into 25%, 25% as a 4 equal parts. This will be our extreme values, minimum and maximum when the data is sorted. So Q1, Q2, Q3 are the quartiles values, where these cuts will happen for dividing the data. Let's go up. So Q1 is also called as first quartile, second quartile, third quartile. Means first quartile means 25% of the data is below the Q1. Once we find out the Q1 value, which we will see in some time, then for taking Q1 value, we can say that 25% of the data falls below Q1. Similarly, 50% data falls below Q2. 75% of the data falls below the Q3. This is the formula. If it is n is an odd, then we will take this formula Q1 is equal to n plus 1 divided by 4. If it is n is an even, the same thing, but if it is n is even, we will get the decimal when we calculate. Which we will see in example. We will come to understand well. So then you have to round up to the next value. But in case of odd, you will not get any decimal. So you directly you can locate the point and you can indicate the Q1 point directly. For Q2, if you calculate, you will not get any decimal, you will get the whole number. So directly we will locate. So no averaging is needed. But here in Q2, you will get a decimal. So you will take the average of I and I plus 1 for locating when the data points are even. Here for calculating Q3, the direct whole number you will get. So directly at that index you will locate the Q3. Here if the index is so, always round up to the next value. We will gonna round up to the next value. But in Q2 we will take an average, but for Q1 and Q3 we will take the next round up value. If we discuss an example, we will come to understand well. So this is the even data set. Let's take an even data set. One second, I will gonna enlarge the data. Anyway, I will be uploading this document. You can go through it and submit by yourself. So this is an even data set. So the n value will be 12. So on calculating the Q1, Q2, Q3, here n means like total number of values plus this is the formula n plus 1 divided by 2, 3, n plus 1 by 4 for Q3, n plus 1 by 4 for Q1. So you will get the decimal. For Q2, if you get decimal means average of I and I plus 1. So here 6.5. 6.5 decimal, this is the index 6.5 decimal, index. So where it will lie 1, 2, 3, 18 and 21. This is the average between 18 and 21. If you take, then you will get the 19.5. Q2, our Q2 value will be somewhere around 18 and 21. This is the Q2. The Q3 is as simple 9.75. The next means 10th means 30th decimal. 30 value will be Q3, same similarly 3.24. then next value, that is fourth index, then it is 12. So these are the Q1 and Q3 for the year. The odd is very simple, you will directly get the whole number. So directly at 6th position, what is there at the 6th position? 24. This will become the Q2. The Q1 at 3rd position will be 12, will be our Q1, and Q3 will be 36. This is how we have to calculate Q1 and Q2, Q3 for the odd and even. So this is our quartile plot. See, the whole of this line will be our data set, and Q1, Q2, Q3 will cut our data set into equal 4 parts. This is the meaning of Q1 and Q3. Why we want this quartile values? Yes, we need it in interquartile range. We will see just in some time what's the use of this. What is interquartile range? This is a measure of statistical dispersion, or how spread out the data is. It represents the range of middle 50% of a data set and helps identify the outliers. What is interquartile range? Mainly it represents the middle 50% of a data set. To see the plot, IQR. This is the IQR plot. The middle 50% will be represented by IQR. Our IQR represents only this 50% of data, Q3 minus Q1. Why we want this Q3, Q1, we will see. Why we want means mainly to detect the outliers. Formula for firstly we will see how to calculate the IQR, Q3 minus Q1. Before we have seen how to calculate the Q1 and Q3, we will go to calculate it, and then we will calculate IQR. IQR measures the spread between the quartiles. So for example, this is our data set. From here to here, we have located Q0. Q0 is the extremes value, Q0 and Q4, nothing to calculate. And then Q1, Q2, Q3, based on the odd and even, we have seen previous how to calculate it. And now this is for the odd set. Then Q1 will be n plus 1 by 4, 3n plus 1 by 4, Q3 we have got the Q1, Q2, Q3 values. We have located the Q1, Q2, Q3. So now calculating the IQR, Q3 minus Q1, this is the 14. What we will do, taking this IQR value, what we will do means, we will calculate the lower bound and upper bound. The formula for the lower bound and upper bound is Q1 minus 1.5 times of QR, Q3 plus 1.5 times of QR. On calculating the lower and upper bound for the above example, take the example for this same example only, we have got the lower bound and upper bound as minus 15 and 41. Where we will apply this value is, this will be the minus 14 and here it comes the 41. So any values coming less than minus 15 and more than 41 will be considered as an outliers. Why we use this quartile? Why we use this percentile, quartiles, IQR, and finally 1 to 1 will link like this, finally to identify the outliers. This is the whisker plot. Whisker plot is which helps to identify the outliers. Whisker point is from here to here. This is a whisker length, which could be maximum Q1 minus 1.5 into IQR. This is the length at both the sides. Here the whisker point, here it comes, and then any values less than this will be considered as outliers. Today we have seen the range, percentile, quartiles, IQR. That's all for the video. Thank you.